Okay, guys, welcome to Simple Probability Day 2. And let's run down here. And today we are going to take just a look at some new vocabulary that doesn't seem like it can be tricky, but you can get caught up in sort of overthinking certain parts of this. So the impossible, impossible means that your probability is equal to 0, okay? Something that is certain means that your probability is equal to 1. Sorry, let me erase this also. Okay. And something that is likely is between 0.5 and 1, or 1/2 and 1, or 50% and 100%. Okay, so what does that mean? If I were to say there's a 60% chance that you guys are all going to pass your exit ticket tomorrow, that would be a likely scenario. Okay. However, unlikely means that your probability is between 0%, 0 and 0.5, or 0 and 1/2, or 0% and 50%. Okay. So if I were to say there's a 40% chance that it's going to rain tomorrow, that would make it unlikely. Now you might be wondering, hey, what about this 0.5 or this 50%? We call that equally likely, right? So if you see something that is 0.5 or 1/2 or 50%, our word for that would be equally likely. So let's just go ahead and label this sort of number line. Now, the number 1 is sort of what we're using for 100%, right? That's sort of like the probability of an event happening. So down here at 0, all the way at 0, I have impossible. And in the middle, I have equally likely, or you could say as likely as not. And then all the way over here at 1, I have certain. So all of these areas in here represent this sort of unlikely and likely. So if I have 4 quarters in a bag, what are the chances that I pull out a quarter? Well, they're certain, right? Because it would be, okay, if I have my 4 quarters, Q. Okay, so my possibility of getting a Q is 4 over 4, which is equal to 1, okay? My possibility of getting a dime is 0 over 4. Okay, so that's impossible. All right, and then sort of in between, let's just say I have 4 quarters and 4 dimes. So Q, 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 oh, whoops, D, D. All right, my chances of pulling out 1 quarter in this scenario is 1/2, 0.5, okay? Or it's equally likely that I would pull out a dime and a quarter. Now let's say I take away one of these dimes. Actually, I'll take away 2 of the dimes, cool. All right, and so my possibility in this case of pulling out a quarter is equal to 4 out of 6, okay, which is 2/3, 66%. So it is likely, because it's likely, I feel like that looks weird the way I wrote it. Okay, likely, and then my chances of pulling out a dime would be 2 out of 6, which would be unlikely. All right, so that's our sort of quick review or quick overview. All right, and we'll take a look at our guided practice. I'll read the directions. For each, determine the possibility of the event occurring, then classify the event as impossible, unlikely, as likely as not, likely, or certain. So that's sort of my spectrum here of 0, and then I get here to 50, and then I get here to 100%, okay? Okay, so rolling an even number on a cube labeled 1 through 6. So on my cube labeled 1 through 6, I have 2, 4, and 6. So my fraction here is 3 over 6, which is the same as 1 over 2. As a decimal, that is 0.5, and as a percent, that is 50%. So I'm going to call it equally likely, right? Or as likely as not. Okay, let's see here. Spinning a number greater than 2 on a spinner with 10 equal sections marked 1 through 10. All right, so that would be an 8 out of 10 possibility, which is equal to 4/5. As a decimal, that's 0.8. And as a percent, it's 80%. So that is likely. Well, let's move down here. Moved too far. Drawing a red marble from a bag with equal numbers red, blue, and green marbles. Okay, so if I have equal numbers red, blue, and green, that means that 1/3 of the marbles are red. Even though I don't have the actual number of marbles, I do know that since it's an equal number of each, I can say confidently it's 1/3, okay, which is equal to 0.3 repeating, which as a percent is 33.3 repeating percent, okay? So this is unlikely because it's less than 50%, more than 0%. All right, and for D, flipping a coin and getting either heads or tails. Well, the only thing on my coin is going to be heads or tails, so I'm going to go ahead and put 2 over 2, which is equal to 1 whole, which is equal to 100%, which means this is certain. Okay, and so in ranking them from least likely to occur to most likely to occur. I can go back here and I have unlikely, right? I don't have an impossible, but I do have an unlikely, which is C. All right, do I have sort of a 50-50? Do I have an equally likely? Yep, I'm gonna go up here. Yes, that's A. All right, and then I'm looking for a likely to happen, so that's B. And the one that is certain to happen is D. So sort of on my scale from least likely to more likely or certain, it goes C, A, B, D, because I went from, again, unlikely, equally likely, likely, and certain. Okay, so again, none of this is super hard, but it is getting caught up in all of this vocabulary can be it can be easy to make a silly mistake, and so we want you to be very careful when you're working. So let's take a look at the independent practice mile, then we'll look at a couple of the homeworks, and then we'll call it a day. So at a carnival game, you win a prize based on the result of spinning the spinner below. What percent represents the approximate probability of winning a keychain? Okay. So we're going to call, we have 6 here total. We're going to call them equal. I think they are. I can't really tell, but we're going to call those equal. Unless it says they're unequal, we'll call it equal. All right. So what is the chance of winning a keychain? So I know that my denominator here is going to be 6, and I have a keychain here, and I have a keychain here. No prize, baseball hat, no prize. So my chances are 2 over 6, which is equal to 1/3, which we know is equal to 33.3 repeating percent. Over here, they have it as 33%. All right, so there's a 33% chance. Mina tosses a number cube labeled 1 to 6. What is the probability that it lands on a 3? Okay, so it is 1 in 6. There's a 1 in 6 probability. When I divide 1 by 6, I'm going to get 0.16 repeating, which is pretty much 17%. 0.17 or 17%. What is the probability it doesn't land on 6? Well, that's way more likely. Oops, that's 5 out of, oh, doesn't land on 3, sorry. That is 5 out of 3. All right, which gives me a 0.83 repeating, the 3's repeating, which is equal to about 83%. Okay, here I rounded up because of the 6 repeating, rounded me up to 7 in my hundredths place. Here the 3 repeating wouldn't round me up, so I would say at 83% in my hundredths place. Okay, let's move down to, oh right, and so the sum of my answers A and B is pretty much 100%, right? I have about 17%, about 83%, so I have 100%, okay? Moving down to, we'll take a look at homework quickly. Homework day 2. All right, we'll just do number 1. If you have a bag of Starburst, forgive me, with 12 cherry, 6 orange, 4 lemon, and 3 strawberry. All right, so that's 18, 19, 20, 21, 22, 23, 24, 25. So it looks like I have 25 total. I feel like that's all going to disappear. No? Okay, so I have 25 total. All right, my probability of getting cherry, okay, is 12 out of 25. All right, and so in order to find the percent, I'll take my calculator and I'll divide 12 by 25, and I will get 0.48. or 48%. All right. Okay, orange or cherry. So that's 18. So I have 12 cherry and 6 orange. 18 over 25. I will divide 18 divided by 25, and that gives me 72%. My chances of picking watermelon. Cherry, orange, lemon, strawberry. 0. 0 out of 25. There are no watermelon. My chances of picking not lemon. So that's cherry plus orange, which is 18, plus strawberry, 19, 20, 21. So that would be 21 over 25. So if I divide clear 21 divided by 25, I'm going to get 84%. My chances of getting cherry or strawberry, I have 3 strawberry and 12 cherry. So that's going to be 15 over 25. And when I divide that, 15 divided by 25, it equals 0.6, which is 60%. All right, guys, simple probability. Make sure you get all your homework done. Make sure you're reading all the words. You're not getting tripped up by language and not making silly mistakes. And good luck. Have a good night.